Hello everyone. This month is called Nonfiction November, and the idea, of course, is that you read at least one nonfiction book in this month. Well, I haven't done that, and I'm not going to do that for the rest of the month, even though I do have one that I wanted to read this month. It's not sitting here with me right now, but I'll get to it when I get to it. But when people were talking about it, I looked and thought, well, most of my nonfiction is a couple shelves worth of science-related material, and I thought, why not just show that off a little bit? And so I got a stack. And what you have, just to start out, this is called The Science in Science Fiction, edited by one Peter Nichols. This is an older book, came out in the early 1980s. And this is just something wonderful for the layperson. Doesn't get too technical with you. It's just an explanation with lots of nice illustration, so it's easy to absorb. Journeys into space, the secret is energy, aliens, limits of the possible, time travel, Holocaust, intelligent machines, men and Superman, dreams of a nightmare future, powers of the mind, mysterious past and present, and where science fiction gets it wrong. This is not a, you're not going to find a pro mind powers and pro ghost stories in here. This is literally why none of it's true. This is a great lesson in critical thinking, and I think if a book like this could be turned into a textbook, taught sometime around junior high, be a lot less con men in every walk of life, from science to politicians, getting away with crap. Just to give you a few little tidbits in here. So this is a diagram of our interstellar neighborhood, about 15 light years across. Earth's in the middle there. So these are all the nearby stars. This is one of my favorite things. This was designed in the 1970s, and it is an illustration of the inside of this, extreme close up, and you see the view you get inside this ring and the environment you can create and control in there. There's nothing that breaks the laws of physics here, but trying to, you know, say, is this justify the cost? No one knew what the cost was and what kind of economics you could get out of it, especially when you consider that the International Space Station, which could fit in here very easily, will end up costing us over $140-something billion, and we got that instead of this. I remember hearing that some Russian scientist called this shopping malls in space. What are you gonna do? Let's see what we can do here. The next simplest thing. This is called Designs on Space Blueprints for 21st Century Space Exploration. And a good example of what's in here is a text setup with some basic diagram of what the subject is. In this case, solar sailing. You put that in space and it will capture it'll be pushed by the pressure of the light of the sun. These would be really slow to accelerate compared to chemical rockets. Similar in ability are ion rockets, which we actually used to some extent, and one took, you can launch it via chemical rocket to escape velocity and get it going in the solar system. But they tested one to go from low Earth orbit to the moon, and it took a few months, whereas chemical rockets take a couple of days. But there's no fuel expenditure, and it's unmanned. A better way would be something like this, but a little more durable, and you shine a laser light on it, and the acceleration and possible top-end speeds can be very drastic. There is a project called Starshot, which wants, instead of a large sail, you make a little bunch of tiny ones, literally no bigger than my hand, but you create a fleet of 100 of them, shine a laser light on them, and then at some point they'll get up to, I want to say it was like 20% of the speed of light, and get to the nearest star in about 40 years and give us a nice picture of what's going there. That would be a prelude to I mean, really, if we set up a laser system pushing sails across the solar system, we could do very well and get to places very quickly. I have on my shirt here a little illustration for you. Get it down here. There it is. So you got sitting on this rock, asteroid, astronauts, and these are the sails in the background there, giving you an idea of the size of them. Alrighty. What's next? Another good basic explanation of things, cycles of fire. This, just for the artwork alone, is worth any price. Just right there, there's your artist right there across the top. And probably my favorite is this right here. Let's get that glare off there. And what you're looking at is a globular cluster of stars in the back. So this is their world. And right down here, this alien here has come up from this lava area. And this guy here has come down from the mountains, and they're meeting together, having a little shindig, maybe trading, bartering, what have you. To think that something like that could actually be going on in a far-off system, I like that idea. Cycles of fire. Oh, here's a classic. Our universe. I've seen this in a few homes of people I've come to know in life. It just gives you a basic rundown of the solar system itself, and probably the most popular picture in there is a view from inside the rings of Saturn. A lot of the I think all the gas giants have rings, but not to that extent. Right there. This is a drastic one. Still, good explainer here, this fella, John S. Lewis, Mining the Sky. This is about asteroid mining and planet mining. So, as an example of what he explains to you here in this book, see this? It got wet, it's all messed up one day. I spilled something on. The content of just our asteroid belt alone, which rests between Mars and Jupiter, would be enough to house and provide energy for quadrillions of people. That's just in our solar system. And that's just the asteroids. Doesn't include what we can do with the planets. So sometimes after I've read this book, whenever I hear a science fiction, someone go, oh no, the Earth is depleted of resources, we have to go to the stars. No, you don't. It's all sitting right here. We've got enough right here in this solar system for as many people as you can dream of. I'm reading this right here. This is so far pretty good. I haven't got that far. Exodus, Peter F. Hamilton. Oh no, the Earth is depleted of resources. We got to leave. And that's what this book is about. Not really. No. It's all sitting right here. We just got to make the stuff to get it. Very related to that, life among the asteroids. This is more about getting around. This is by Jerry Pournelle, Paul Anderson, Jerry Pournelle, Charles Sheffield. The one fun one in here is it's by Jerry Pournelle, and it's called Those Pesky Belters and Their Torch Ships. Because the idea is that you make fusion drives and you get out and you hop around the solar system at 1 g of acceleration, which if you go that fast, that's 22 miles per hour faster every single second. And if you can achieve that, one, you'll have gravity on your ship that feels like you're sitting here right now. And two, things like getting to Mars in a couple of days, getting past the orbit of Pluto in a month. If you keep going and are able to continue that acceleration, in 2 years, you'll get very high percentages, over 90% of the speed of light, if you can maintain. But in that particular article in this book, he explains that that's a lot of heat in your fusion drive to get rid of, and we just do not have anything remotely like that capacity. Another kind of science and science fiction book right here. Stan Oldenwald, The Astronomy Cafe. There's two of these books. This one has a sequel, and so you just have a question and answer session. Is there a name for the second moon in a month? when I first received this question at the Astronomy Cafe, I said that I didn't know of any such names, but then several readers contacted me and said the second new moon is sometimes called the finder's moon, the secret moon, or the spinner moon. You learn something new every day, and the whole book is like that from every astronomy topic that there is. The Case for Mars by Robert Zubrin. I don't know if this is considered out of date. I don't believe that it really is. Everything is all, he did all the math for you and the chemistry for you. The idea is you send a rocket to Mars. It lands on Mars. It is unmanned. While it's there, it's going to start using this a particular motor to get what it needs out of the atmosphere of Mars and create methane rocket fuel. There will, I think there was to be already stuff to eat and drink on the rocket. Then the manned rocket shows up. Oh, good, we already have provisions, and of course bringing some with us also. Now we do our thing, and we come back using that one because we have rocket fuel from the first rocket, and then you keep sending unmanned, manned, unmanned, manned, until finally you get a little town of these rockets all put together, and you start getting on Mars, doing some mining and whatnot like that. SpaceX might be doing something like that, using much larger rockets at low cost, it appears. This one was going to be, I want to say it was going to be $20 billion initially, and then a few $1 billion a year to upkeep and keep it going through NASA. Well, no one took the plan. No one gave a damn. Here's a good, cheap way to do it. And they said, well, we're not doing that. We're NASA. Star Trek, The Physics of Star Trek by Lawrence M. Cross. Poor guy had a social issues in his life, but he does have a good YouTube channel now. Did I do this already? Was I not paying attention? I think I did, or didn't I? Oh well, I'm not gonna edit, so whoops. Yeah, I did do this. Didn't I? Oh well. All the stuff going on in Star Trek, from holodecks to fascism, light travel, and why you can or cannot. This here is one of my favorite topics. Immortality by Dr. Ben Bova. If you have been, I was watching, who was I watching today? It's one of my favorite chapters. And she made a offhand comment about, well, if I make it to the age of 99, because it's her birthday this month, well, you just might, and then some. And so right now you have a couple of things coming down the pipe, some of which are, I think, were discussed way back when in this book. Now, this is in the 90s, I think it was. And so, for example, you have your thymus up in here somewhere, and it starts getting smaller and smaller from like the age of 20 on. By the time you're like my age, it's like half the size that it was when you were 20 years old. And through 3 chemicals put together, it regenerates the thymus and grows it back. And people who have taken this, you have various ways to measure. They call it measuring someone's age, but it might be more of a measure of someone's overall health, like their body. They might be 50 years old, but their body's functioning like someone in their 30s, and that's a good thing. And that's what this, they call it an epigenetic clock. And so people who have been through the process, maybe they, as I said, start out, it says their clock is 50, and then not only does their clock say they're 35, but dudes with gray hair get their regular color hair back. And so you're getting a regeneration of youth. Now, this is more akin, it sounds like, to just making you extremely healthy. I don't know that it means you could live to 150, but it's a pretty damn good sounding start. Another one I had recently watched a video about had to do with taking your mitochondria and cloning it and injecting a young version back into your bloodstream, and it just rejuvenates you as well. So if those are not, at least at first, the nitty-gritty to turn us all youthful again, It's the kind of thing they talk about health span. And so let's say you're going to run 100 meters, and 100 meters, that's your lifespan. And you start out sprinting, then you kind of get to jogging, and then you're walking, then you just drop dead at the 100-meter mark, and that's your normal lifespan. So doing some of the things that are coming down the pipe, like filtering out your blood plasma, you take out these chemical factors that have helped age you, and you filter it out. You have a blood transfusion with yourself. You take those factors out and you replace it with a saline solution and a particular protein, and wham, people have had their arthritis go away. People have had their back pain go away. People have had, they're elderly, still look elderly, but they're like, I have energy now that I didn't have, that I haven't had for 10 years. And so the idea behind that would be that you start sprinting your 100 meters, and you start jogging your 100 meters, and by the time you get to your 100 meters, you're still basically jogging, and it's only afterwards that you start to walk a little bit, so you punch past what would have been your normal lifespan and get a few more time. And getting that more time means that some other process comes along that's even better, or improved versions of what you've already had, and so on, and hopefully you live a much longer time. Speaking of which, Year Million, Science at the Far Edge of Knowledge. So this has a lot of contributors. There is immortality talk in here. My personal favorite is this fellow, Robert Bradbury, not Ray Bradbury, the author, Robert Bradbury. He was talking about dysonspheres, or swarms, objects surrounding the sun in a cloud to collect all its energy. But instead of just collecting the energy, it helps power a thinking process. So you get an artificially intelligent Dyson cloud, and the power of this thing would be enough to process the entire history of human thought in a few millionths of a second. This is the sort of thing when people talk about maybe you're living in a simulation. Well, there's one way you could potentially be doing that. And now, he was a big proponent of immortality for people and life extension, human rejuvenation, and getting to this point where we can take apart parts of our solar system and surround the sun and collect its energy eventually. Unfortunately, he passed away, I believe it was 2010, from a massive stroke, an aneurysm, and it killed him. That was really sad. I exchanged a few emails with him, and we talked about thinking dysonspheres for a little bit. That was way back in 2001 when I first got my very first computer. Quickly now, this is called Where is Everybody by Stephen Webb. So here, this is a variety of topics, just a few pages per topic. 61, page 62, 70, just 2 to 10 pages on a given topic. Reasons why they haven't communicated. The stars are far away. They stay at home. They surf the net. They're signaling, but we don't know how to listen. Berserkers. Berserkers would be sort of like 2001: A Space Odyssey, but instead of just sitting there waiting, it decides to start eating things and make duplicates. If you've seen the sequel, 2010, it drops a monolith in Jupiter and it starts doubling itself. Now it has 2, then 2 can make 4 and 8 and 16, and depending how quickly it can replicate itself, it can just eat the solar system in whatever amount of time. Or sitting down and grabbing up resources and building itself up into a weapons platform and just laying waste to anything that is viewed as competition. If you've heard of the 3-body problem, that's the idea behind Berserkers. And there's a whole an old science fiction a series called Berserker Wars by Saberhagen. I read one when I was young. I think it was a little over my head at the time. I just liked the spaceship picture on the cover of it, but it was my start into that world there. That's all I got. That's all I stacked. Well, there you go. some choices for, well, not just Nonfiction November, but whenever in the holy hell you want to get some science in your life. Especially, I'm not even kidding when I say this is probably your best start right there if you want to have a nice coffee table book to browse on occasion. I did a video on this one by itself, just pointing at it, but it wasn't a very good video. I think I deleted it. I'll have to go look for it later. That's it. Thank you very much. Have a good time. This happens to be a chunker. This is 800 or 900 pages. Might be a while for my next video, especially when I start working again this week. Thank you very much. Bye-bye now.